Hello and welcome. Today, we're going to peek behind the curtain a little bit. We're going to go on a journey from the source code we all write every day to the hidden structure, the secret map that compilers actually see.
Okay, let's just jump right in with a question. What could a simple typo and a legendary programming hack possibly have in common? I know, it sounds impossible, right? But the answer actually reveals a much deeper truth about how our programs really work. Turns out, they're both about controlling the flow of execution.
You know, when you really boil it down, a huge chunk of programming is just about making decisions. We're constantly telling the computer, hey, if this happens, go this way. If that happens, go that way. These are the crossroads in our code.
And to handle these choices, we have our trusty tools. We use things like the if-else statement for a simple yes or no choice, and when we've got a variable that could be one of many different things, we'll often reach for a switch statement. These are kind of like the basic road signs we use to give our program directions.
But what happens when we mess up those directions? Even a tiny little mistake, a single character out of place, can send our program careening down a completely unintended path. And that leads to bugs that can be a real headache to track down. All right, check this out. This is one of those classic mistakes in C that gets everybody at some point. At a quick glance, you'd think it's checking if the variable here is equal to the variable there. But it's not. See that single equals sign? That's not comparison. That's the assignment operator. So this code is actually setting the value of here to the value of there. And in C, that whole expression then evaluates to whatever that new value is. So unless that value is 0, the if condition is always true. It's such a subtle and nasty bug. And if you thought that was sneaky, take a look at this one. That tiny little semicolon at the end of the for loop line, it is perfectly valid C code. And honestly, that's what makes it so toxic. The compiler won't complain, but your program is now completely broken. So what's actually happening here? Well, because of that rogue semicolon, the body of the loop is just an empty statement. The loop runs 10 times, it increments x up to 10 just like it's supposed to, and that's it. It does nothing else. That whole block of code in the curly braces, the part you actually want it to repeat, yeah, that gets ignored entirely. And hey, let's not forget about our old friend, the switch statement. This is another place where it is super easy to shoot yourself in the foot. In C, you have to explicitly tell the program to stop after it finds a match. If you forget, well, things get weird. If you forget that break statement, the program runs the code for the case that matches, and then it just keeps on going. It executes the code for the next case and the one after that until it finally hits a break or gets to the end of the switch block. This is called fall through. And trust me, 99% of the time, it is not what you want to happen. So you see, all these bugs, they happen because we're looking at our code as a list of instructions, but we're misunderstanding its actual flow. To really get a grip on this, we need to stop thinking like that. We need to zoom out and look at our program's real blueprint.
And that blueprint has a name. It's called the control flow graph, or CFG for short. This is the secret map that compilers use to understand the true structure of your code long before it even thinks about running it.
Seriously, think of it like a Google Maps for your code. Every straight line chunk of code with any jumps is a location on the map. We call it a basic block. And every decision point, like an if statement or a loop, is a path connecting those locations. Compilers build these maps automatically. It's a pretty straightforward process, really. They scan your code, find all those basic blocks, and then they draw arrows between them to represent every single possible path the program could take. This map is what lets them analyze and, more importantly, optimize your code. Okay, so this is where it gets really cool. Because once we have this map, we can use it to see exactly why those common mistakes we just talked about are so problematic. When you see it this way, the bugs become just glaringly obvious. Let's go back to that nasty little semicolon in the for loop. We know it makes the loop do absolutely nothing, but it can be hard to visualize just by staring at the text. So what happens when we draw the control flow graph for this one line of code? Well, the error becomes completely undeniable. The map does not lie. When you look at the CFG, it's crystal clear. You see this little node for the loop pointing right back at itself, a tight little circle representing that empty statement. And the code you actually wanted to run inside the curly braces, it's just sitting over there, completely disconnected. It's an unreachable island, totally isolated from the program's flow.
But here's the thing. If you can read the map to avoid getting lost, you can also use it to find some wild, mind-bending shortcuts. And that brings us to a legendary piece of C code known as Duff's device, which is a brilliant, if not terrifying, example of manipulating control flow.
I mean, just look at this. At first glance, this code looks like it should be totally illegal. It seems to break every rule of structured programming we've ever been taught. You've got a switch statement and a do-while loop all tangled up together. A case label is inside a loop, which is itself inside the switch. What is going on? So what in the world is the point of this craziness? Well, it all comes down to a performance trick called loop unrolling. The idea is to make something like a memory copy way faster by reducing the overhead. Instead of checking the loop condition on every single copy, you do a batch of copies at a time. In this case, 8, to cut down on the number of jumps and checks.
And the reason this crazy thing is perfectly legal in C is because of how switch statements actually work under the hood. A case isn't some self-contained block. Nope. It's basically just a named entry point, a lot like a goto label. So the switch statement does its calculation and then jumps directly to the right starting point inside the do-while loop. It's wild.
And if we were to draw the control flow graph for this, it would look insane. You'd see all these different entry points jumping right into the middle of the loop's body. It's a mess of crisscrossing, but totally valid paths. It's an incredibly efficient but absolutely mind-bending shortcut that's only possible if you really understand the code's true map. So understanding your program's true map, its control flow graph, it isn't just about dodging bugs. It's about seeing your code on a whole new level, the way the compiler does. And it makes you wonder, right? If something like this is possible, what other so-called illegal shortcuts are just hiding there in plain sight, waiting to be discovered?